Hello everyone, my name is FATIMA. Today my colleague SOHAILA and I are going to present our project. Things we'll be covering are the site analysis and climatic analysis, the design, the dynamic facade, the IES simulations and results, then adapting renewable energy strategies, and then last but not least, the conclusion. Sustainability is a term we often hear lately worldwide, and we often link it to the green energy and the global warming topic. Nevertheless, sustainability is a bit deeper than that conception, where it's a group of links that are codependent on each other, which includes human activities, buildings, energy consumption, etc. In this project, we'll be focusing on the building aspect and its impact on the environment. Our aim is to minimize the energy consumption using innovative design ideas, such as implementing the kinetic facade system. Our project is a library situated in the northern part of Italy, in a city called Verona. The plot is surrounded by educational institutes and residential houses. Verona is considered to have a temperate climate, cold in winter and warm in summer. The plot is accessed from two roads, one on the north and one on the south. Therefore, any potential noise will be sourced from them.
Verona is considered a city with a temperate climate, where it has a cool winter and warm summer. As it's shown in the chart that the warmest month is July, with highs of 32 degrees Celsius, while the lowest temperature recorded in January is -3 degrees Celsius. The wind road shows that the dominant wind direction is from the southeast.
The design of the library evolved from a simple rectangular geometrical form, and given the restrictions such as the climatic analysis and sun path analysis, the form has took its shape. The library is a two-story building that aimed to serve both the neighboring educational and residential communities. The building will be using some passive design strategies such as convection ventilation, with the help of the double-height spaces to circulate the air, along with the sawtooth roofing system to enable skylight and help with the convection ventilation process. Our dynamic facade is inspired by the shark gills, which has a fascinating mechanism to bring in oxygen to its system. The facade will replicate the idea and therefore capture the passing wind and at the same time prevent sun glare at certain time of the year. The biomimetic kinetic facade is basically vertical strips, which are the bending components. These components are going to curve at different angles depending on the time and season. The material that will enable this kinetic facade to curve is the fiber reinforced polymer, where it has the necessary bending quality.
As per one of the green building rating system accredited in Italy, which is BREEAM, the maximum allowed U values used for roof is 0.18, while for the walls is 0.15 and for the window glazing is 1.7. The study will show a comparison of the energy consumption from different cases, which include the following: the base case, the efficient case after applying BREEAM minimum requirements, the kinetic case after implementing the kinetic facade. To analyze the energy consumption in each of the three cases, each case will be studied in 3 different seasons. 2nd of July is being the highest mean temperature in summer, while 12th of January is the coldest day in winter. 9th of October is the day with the uncomfortable mean temperature value in autumn. 3 different simulations will be conducted for each of these days: 9 a.m., 12 p.m., and 3 p.m. Starting with the summer season that is presented by 2nd of July. At 9 a.m., the energy consumption for the base case is around 29, while in the efficient case is around 26, as it shows approximately 10% reduction. While on the same day at 12 p.m., the energy consumption was 41, and the efficient case was 40, as it reduced slightly by around 2.4%. The last selected timing is 3 p.m., which the energy consumption reduced for about 6%. Next is the winter season. The energy consumption of the building at 9 a.m. is 116, while after reducing the materials U value, the energy consumption reduced by 32%. At 12 p.m., the energy consumption reduced by 43%. At the time of the last analysis, which was at 3 p.m., the consumption significantly reduced by 57%. Finally is the autumn season. The third selected day is 9th of October. At 9 a.m., the energy consumption is around 32, and it shows a reduction of about 10% in the efficient case. At 12 p.m., it has been slightly reduced to 2.4%. While at 3 p.m., the consumption reduction was 6%.
As part of the kinetic case energy consumption and with the help of Revit and IES, we obtained the annual energy consumption. In the base case, the annual energy consumption is 345 megawatt-hour, whereas in the kinetic facade case, the energy consumption reduced to 306 megawatt-hour. Therefore, it reduced by 10% of the total energy consumption. As we can see, in summer, the kinetic facade case has a slight reduction than the base case in terms of daylight factor percentage. We can see a significant difference in the daylight factor coefficient between the base and kinetic case. Where the daylight factor was 43 in the base case, it's 28 in the kinetic case. Going to the winter season, the kinetic facade case has also achieved a reduction in the daylight factor percentage compared to the base case, with a daylight factor of 29 in the kinetic case compared to the base case with a daylight factor of 46. Moving on to the autumn season, although the percentage of reduction for the daylight factor percentage is minimal, we can notice the glare in the areas are reduced from 48 in the base case to 35 in the kinetic case.
Starting with the summer season, the temperature lies between 21 to 36 Celsius for the base case, while in the kinetic case, the air temperature contour has differed significantly where the temperature lies between 22 and 24. Moving to the velocity. The velocity contour in the base case is between 0.10 to 0.62 meters per second, whereas as in the kinetic case, the velocity is between 0.05 and 0.25. Next is the PMV. The predicted mean value indicates how much the space is within the comfort level. The base case comfort level ranges between 0.015 to 2.1, which is a reasonable comfort value. And in the kinetic case, it's even more distributed in the space where the range goes from 0.03 to 0.6. At 12 p.m., the air temperature analysis in the base case varies between 17 to 29 degrees, whereas in the kinetic facade case, the temperature is unified to be around 23 degrees. The velocity contour in the base case is from 0.07 to 0.27 meters per second, while in the kinetic case, the velocity contour is between 0.05 and 0.25 meters per second, which is approximately the same in both cases. Moving to the PMV. In the base case, the thermal comfort ranges between -0.4 to 0.7, while in the kinetic case has a lower range going from -0.5 to 0.10. Finally, in the autumn season, the air temperature analysis during 9th of October at noon is between 17 to 28 degrees, whereas in the angled kinetic facade, the indoor temperature is in the range between 22 to 24 degrees. The base case indicated that the velocity value ranged from 0.07 to 0.40 meters per second, whereas in the kinetic case, the velocity description is more constant with values going from 0.05 to 0.24 meters per second. The predicted mean value of the autumn season for the base case that presented a level of comfort between minus 0.6 to 0.6, which is within the comfort zone, and in the kinetic facade the level of comfort is between 0.05 and 0.3.
Integrating renewable energy to our building will further aid in sustaining the building against harming the environment. As previously mentioned, the base case has an annual energy production of 345 megawatt-hour, and with the kinetic case, it already reduced to 10%, making it 306 megawatt. Hence, with using the northern slanted block, we were able to install 118 PV panels, which will be able to cover 99 megawatt annually, and therefore contribute for 32% of the total energy consumption.